Jordan, tell me if this sounds familiar. It's 2024. You're a facility manager. Your phone buzzes at 2 a.m. It's a notification from your smart HVAC system. It says, compressor B critical anomaly detected. Temperature deviation 15%.
Oh, I know that drill. That's the smart IoT promise we were sold for 10 years. The device is smart enough to scream for help, but dumb enough to just sit there and watch itself burn while I scramble to find pants and log into a VPN.
Exactly. That was the era of the dashboard. We spent billions connecting things, turbines, pacemakers, traffic lights, just to build the world's most expensive alarm clocks. We created massive data lakes, but we left the action gap wide open. Humans still had to do the work.
But we're not in 2024 anymore, Alex. It's January 2026. And looking at this massive report on my desk, that action gap is closing fast.
It's not just closing, Jordan. It's being cemented over. Welcome to DX Today. I'm Alex.
And I'm Jordan. Today, we are tearing apart the most significant paradigm shift in the history of the Internet of Things. We are moving from passive IoT to agentic AIoT.
This is the big one. We aren't talking about ChatGPT writing you a poem. We are talking about software agents living inside physical machines that can perceive, reason, plan, and, crucially, act without human permission.
The numbers here are staggering. I'm looking at the market analysis in this report. In 2025, the agentic AI market was valued at about $7.5 billion. Sizable, but niche. But the projection for 2034, nearly $200 billion. That is a compound annual growth rate of over 43%.
To put that in perspective, that growth rate outpaces the early days of cloud computing. We are seeing a complete architectural overhaul of the industrial world. Gartner is predicting that by the end of this year, 40% of enterprise applications will embed autonomous agents. That's up from less than 5% 2 years ago.
So today, we are going deep. We're going to explain how a thermostat can now negotiate with a blind controller. We're going to look at how a steel mill turbine fixed itself before the humans even knew it was broken. And we're going to talk about the terrifying new security threats, things like memory poisoning that come when you give machines a mind of their own.
Buckle up. The dashboard is dead. The agent is here.
Okay, Alex, before we get into the how, I want to understand the why now. We've been hearing about smart homes and Industry 4.0 for a decade. Why is this the moment everything changes?
To understand the present, we have to look at the 3 phases of IoT evolution. Think of it as the maturation of a child.
Okay, walk me through the baby years.
IoT 1.0, roughly 2010 to 2018, was the connection era. This was purely about plumbing. Can we get a Wi-Fi chip in a fridge? Can we get a LoRaWAN sensor on a cow? Can we get that data to a cloud server?
Right, the era of, look, I can see the temperature of my living room from Tokyo, but you couldn't actually do much about it.
Precisely. It was read-only for the most part. Then came IoT 2.0 from 2018 to about 2023. This was the analytics era. We started applying basic machine learning. We got anomaly detection. We got predictive maintenance.
This is where the dashboards got fancy, right? The system would predict, hey, this pump might fail in 3 weeks.
Yes, but it was still passive. It was a nag. It dumped the cognitive load onto the human operator. If you had 10,000 sensors, you had 10,000 potential nags. It created alert fatigue. Operators would just mute the notifications because there were too many. The intelligence was trapped behind glass.
And that brings us to IoT 3.0, 2024 to present, the agent era.
This is where the rubber meets the road. 2 things happen simultaneously. First, hardware got incredibly powerful at the edge. Companies like NVIDIA with their Jetson line, Qualcomm, and even Apple started putting NPUs, neural processing units, directly into cameras and gateways.
So the device didn't need to talk to the cloud to think.
Correct. And second, we figured out how to shrink large language models, LLMs, into small language models, SLMs, and large action models, LAMs. Suddenly, we had software that didn't just understand text, it understood goals.
That's the key word in this report, goal orientation.
Right. In the old days, you programmed a robot. If X happens, do Y. It was rigid logic. If Z happened, the robot crashed. Agentic AI is different. You give it a goal. Optimize the grid load while minimizing cost. The agent then figures out the how on its own.
It feels like we're moving from a command and control military structure to a decentralized team of Navy SEALs.
That's a brilliant analogy, Jordan. It's decentralized decision-making. We are seeing labor shortages in critical fields, utility operators, specialized manufacturing. We physically don't have enough humans to watch the screens. We need digital teammates.
And the report highlights that this isn't just about chatbots. An agent in this context is a software entity sitting on a gateway, issuing commands to actuators. It's the shift from smart to intelligent.
And frankly, it's about time. The passive sensor was a glorified snitch. The agent is a mechanic.
Okay, Alex, I want to get under the hood. You're the analyst. I'm the journalist who barely passed Python 101. How does this actually work? If I slice open a smart camera in 2026, what am I finding inside that wasn't there in 2023?
Let's break down the agentic stack. It's completely different from the old cloud-centric model. It revolves around something called the perception action loop.
Perception action loop. Sounds like biology.
It is biomimetic. It starts with the perception engine. In the past, a sensor saw data. A temperature reading was just a number, 72 degrees.
Now, using multimodal models, an agent ingests raw sensor data, vibration, thermal imagery, acoustic patterns, and it sees the context. It doesn't just register 72 degrees, it registers 72 degrees but rising rapidly consistent with a bearing friction pattern. So it has context. It's not just looking at a spreadsheet cell, it's looking at the story of the machine.
Exactly. That data is fed into the reasoning core. This is the brain, usually a small language model like Llama 3.8b or Microsoft's Phi 3, running locally on the device. This core uses a technique called chain of thought reasoning.
Hold on, chain of thought? That's what ChatGPT does when it says, let's think step by step, right?
Yes, but applied to physical machinery. The agent literally has an internal monologue. It thinks, 1, vibration is high. 2, current production load is maxed out. 3, if I stop the machine now, we miss the shipment. 4, if I slow it down by 20%, vibration stabilizes and we still hit the quota. That's incredible. It's weighing trade-offs. It is planning. The report mentions Monte Carlo tree search. The agent simulates potential futures. If I slow down the conveyor, will it cause a jam upstream? It runs that simulation virtually before it issues the command.
So it's not just guessing, it's gaming out the scenarios. But Alex, how does the software actually turn the knob? LLMs generate text, they don't have hands.
That is the action gap we talked about, and it's been solved by 2 massive breakthroughs in protocols, MCP and A2A.
Okay, let's tackle MCP first. The report calls it the USB-C for AI apps.
MCP stands for Model Context Protocol, pioneered by Anthropic but now an open standard. Think of it this way. In the past, if you wanted an AI to control a valve, you had to write custom code gluing the AI API to the valve API. It was brittle. MCP provides a standardized way for an AI agent to plug into data sources and tools. The valve controller publishes an MCP tool definition. The AI reads it and says, I see I have a tool called set pressure. I know how to use that.
So it creates a universal language where the software knows what the hardware is capable of, without a human writing a custom driver for every single device.
Precisely. It allows the reasoning engine to read the state of the machine and write commands back to it. But the even cooler protocol is A2A.
A2A. This sounds like the start of the robot uprising.
It's less Terminator and more corporate diplomacy. A2A is a Linux Foundation standard. It allows agents from different vendors to negotiate. Imagine a thermostat made by Honeywell and a blind controller made by Somfy. In the old days, you needed a central hub to coordinate them. With A2A, the thermostat agent pings the network. I am overheating. The blind agent responds. I can lower the blinds to reduce solar gain by 40%. The thermostat calculates. That is cheaper than turning on the AC. Do it.
They are literally bartering energy credits and actions?
Yes, they discover each other, negotiate tasks, and share artifacts. The report mentions a logistics agent hiring a routing agent. We are moving towards a microeconomy of software agents.
And this is all happening at the edge, no cloud?
Mostly edge. Cloud is for long-term storage and retraining, but the split-second decisions, that's happening on the silicon right next to the motor. That reduces latency and bandwidth costs, which makes the ROI undeniable.
So we have eyes, perception, a brain, reasoning core, a way to move hands, MCP, and a way to talk to teammates, E2A.
That is the Agentic AIoT stack.
All right, the tech is fascinating, but I'm a skeptic until I see it work in the real world. The report details 3 major case studies. Let's dig into them. I want to start with manufacturing, the self-healing turbine.
This is Case Study a major steel manufacturing plant. They implemented Agentic AI on their critical turbine units. Now, normally, a turbine bearing failure is a nightmare. It seizes up, the line stops, you lose millions, and you wait 3 weeks for a part from Germany.
Right, and in the IoT 2.0 days, you'd get an email saying vibration high, which the operator might miss because they're on lunch break.
Exactly. But here, the Unit 7 agent was active. It detected a subtle harmonic distortion in the hydrostatic bearing, something a human ear would never catch, indicating failure was about 72 hours out. Here is the chain of thought process the agent went through. Step 1, diagnose the fault. Step 2, check the production schedule, ERP system. It saw a scheduled lull in production 2 shifts from now, a 2-hour window. Step 3, check inventory. The part wasn't in stock locally. Step 4, execute.
What did it do?
It autonomously logged into the procurement system, ordered the specific bearing from a supplier with expedited shipping to arrive before that 2-hour window. It then generated a work order for the maintenance crew, flagged priority high, and scheduled the machine downtime during that specific lull.
So the human maintenance crew just showed up?
They got a push notification. Part arrived at loading dock B. Replace bearing on Unit 7 at 1400 hours. Machine has been pre-cooled for safety.
They did the job. Unplanned downtime was 0. The report says this reduced unplanned downtime by 100% for that asset class. That's not just efficiency, that's a fundamental change in how a factory runs. The machine manages itself. Let's look at the smart grid example, TEPCO and Eneco. This one feels higher stakes because if a grid fails, people die. The stakes are massive. TEPCO in Japan use this for disaster recovery. After a typhoon, usually you have humans looking at maps, trying to figure out which lines are down. It's chaos. TEPCO deployed swarms of agents. These agents ingested data from smart meters, social media feeds, and drone footage. They autonomously assess damage and, this is the key, optimized crew dispatching. So the AI